Thank you everybody for coming on the last day, on almost the last session before the closing keynote. All right. I'm going to try to give you feedback on what we did with WebRTC this year, with 3 different companies coming together, Xerxes, CosMo, and Millicast, with different things. That's the title as it is in the schedule. That's the actual title we would have loved to give it. 2 years of WebRTC fake news, and we didn't want, the American people to feel cornered or stigmatized, so we put the UK people there as well, because there's nothing to be proud of with Brexit. So let's go there to make it a little bit funnier, because it's the last day and the last session. We're going to organize it as a quiz. I'm going to write some statements out there, and I'm going to ask all of you guys that know more than me about streaming, whether you would have thought that to be right or a fake news. So who thinks that WebRTC was not designed for streaming in the first place? Nobody? You guys get out. You guys know, so you saw the slide before. Okay, Paul?
Was not.
It was not. Everybody else? Okay. True. It was not designed for one-way streaming one-to-many, and so it brings a few problems when it comes to trying to do that as a platform, as a service, right? So let me give you one example, and I will give credit to which is a social streaming media platform that has been doing streaming with WebRTC for, I don't know, the best part of the last decade already. Flash first and then WebRTC. WebRTC was designed for two-way communication. So that means they assume that every time I'm going to connect to you, I'm going to send you my video, but you're also going to send me back the video, right? So what does that mean? That means if you do it one way, if you're only a viewer, WebRTC is still going to ask you permission to access your microphone and your cam. So on your mobile app, let's say you have the Netflix app that suddenly asks you to switch on your camera and your phone. That doesn't go very well with the users, right? And that's because it was assumed that it will always be both ways. It will be like a FaceTime thing. So found the bug and found a way around that because Google didn't want to fix it in the code. So WebRTC was or was not designed for multiple hops. Is it true or not true? We want to risk.
False.
False? So you think it was designed for multiple hops? No, it was not. So WebRTC, the original use case was P2P one-to-one. Again, it was FaceTime and so on and so forth. So that makes a lot of problems when you want to do multiple hop. The problem of qualities, and I'm going to give you the example later. So all of those 3 points are going to be details with drawing, right? Problem of security, the encryption is actually only hop by hop. So if you put a media server, for example, the media server needs to be trusted because he has access to the raw content and so on and so forth. So let me give you an example of the quality problem. WebRTC, just like voice over IP, is based on RTP protocol, which is in turn works better when it's running on the UDP transport network protocol. So now you have a source that is going to do the encoding and broadcast, and it's going to go through several media server cascading or in a tree, you call it the way you want, before it actually hits the viewer. And you can have millions of viewers like that connecting, viewing the same stream from the same source. If a single viewer is on a bad link, the red arrow here, bad things will happen by default. First, it's going to tell you, I didn't receive the packet. Right, so packet loss is really high. I didn't receive the packet. So most of the media servers nowadays are smart enough to have a little packet cache, so you don't need to go back all the way to the source. You just, resend the packet. It keeps it for a certain amount of time. Life is good. It's been done for 20 years by most of the voice over IP server that use RTP, no problem. The problem is when you lose the second packet again and the third packet again. Well, the network is really too bad that there is no other choice. The encoder cannot wait anymore, and is going to request a full frame. So the only one that can send you a full frame is the original encoder. And so that viewer will send, because it has a bad network locally, will send a request for a full frame all the way down to the encoder, to the source, which in turn will send a full frame to everybody, all the viewers. And a full frame takes more bandwidth. So now you have what we call a nosy neighbor. And the problem with that is because it was never thought in a design of the RTP that you will have a single source for that many people. And the more people you have, the more likely it is to happen that you have at least one that is trying to connect with the conference Wi-Fi, right? Or hotel Wi-Fi or something like that. So while doing WebRTC at scale is doable with the usual scaling approach, clustering, auto-scalability, and so on, while you can keep the latency relatively down, achieving that with the same level of quality you have with WebRTC use in a video conferencing world is challenging. And an easy way to test if people do that well or not is to do exactly that setting. You put 5 devices or computer connected to one stream. You artificially add packet loss to the network. On Mac, there is a very simple app provided by Apple to do that. And you check if the other people are impacted. If they are impacted, that means the WebRTC service didn't go very, very far in addressing the limitation of WebRTC itself. The second problem is the security. SRTP, the secure RTP, is a hop-by-hop encryption scheme. So in a P2P mode, because you have only one hop, then it's end-to-end encrypted. So it's secure, but it's not scalable. To scale it, you put a media server. So you're scalable, but then you're not secure anymore. Because the encryption is hop by hop. It's going to be between Alice and the media server, and between the media server and Bob. And there will be different secure tunnel with different keys, different DTLS exchange, and so on and so forth. So if someone has access to your media server, he has access to all your media in row, right? If you want to do it right, you need end-to-end encryption on top of the original WebRTC encryption. So WebRTC encryption will be the blue tunnel, and it will be hop by hop between Alice and the media server and Bob, if there is only one, and then between all the media server if you have a longer chain. But the end-to-end encryption will be all the way between Alice and Bob. So even if the media server or the recorded content is compromised, it's still encrypted with a green key that only Alice and Bob have, and the media server is not trusted with. That's the Telegram or WhatsApp approach. So with Cisco and other people, there was a standard group that was created for that called PERC, Privacy Enhanced RTP Conferencing. It's basically for the biggest two protocols that were based on RTP, namely SIP and WebRTC. It's not completely finished. We're closing it right now. There's still a few discussions about the trust model. It's only for RTP media transport. So people that want to do something else like QUIC or WebSocket and so on, there is no technology for you existing today. And there is a variation called PERC Lite, which is the only one that we know of that is used in production today by Symphony Communication. And this one has been validated by the SEC for all the bank level communication and traceability of this. So the bank have their own secondary key that they don't share with anybody, and then they can trust even if they run the media path over Symphony servers. In WebRTC next version, which is the name they give to WebRTC 2.0 if you want, there is also something called E2EME, end-to-end encryption for end-to-end media encryption, which is a little bit more evolved. It's transport agnostic, so it's not limited to RTP, because they're thinking about QUIC already. And it's not per packet, it's per video frame. So you encrypt your video frame before you chunk it and give it to your media transport. So then if you want to use HLS or something else after, it doesn't have to be WebRTC, it works. And since you do it per video frame and not per packet, there's also lower overhead. So this is coming in your browser around next year. And for people that want to do end-to-end encryption with WebRTC today, PERC or PERC Lite are the easy target, and they address that. Finally, there is also a problem with the bandwidth evaluation. The RTP, RTCP protocol suppose that Alice and Bob can have a direct link to each other and probe each other bandwidth, right? There is only one hop. If you put a server in the middle, it's still kind of okay because the server still sees both ends. They can probe the bandwidth and make the choice for them. But if you have multiple servers and you're in real time, there is no way for the broadcaster and each of the viewers to probe each other bandwidth. right? So if you try to use WebRTC out of the box, that becomes a problem as well. Most of the time, the viewer bandwidth evaluation is more important than the broadcaster. You suppose that the broadcaster is in control environment with a good studio-like setting and so on. What is very important is to deal with the viewer, so you can make some smart adjustment into the media, the viewer node, the media server that serves directly the viewer to do the right thing. But it doesn't work out of the box. All right, so a lot of people say, oh, WebRTC is too new, and one of the problems we have with WebRTC is there is not enough tool for people to really test all the fantastic claims that we get from all the vendors about scalability, about quality, and so on and so forth. So I'm reduced to actually believe what the people say because I have no way to test. And everything I had before doesn't exist. So is that still a true statement or not? Nobody wants to win the prize. Paul, you go for your point number 2?
No, it's not a true statement.
That's correct. So, fake news. I love that stamp. So in 2016, the W3C, the WebRTC working group on the broader side, recognized that there was a problem. So we did that little drawing there that was a very simplified case. Only one-to-one P2P, no multi-party, right? And only a few operating systems and so on. And we should test 496 one-to-one call to cover everything and make sure it works. We were doing 5, and only on Debian Linux, which is not exactly representative of what the people were using when they go on the internet. Or at least my mom is not using Debian Linux for that. So in 2016, we came to the realization that we had a problem. And within the standard committee, we proposed a new design called Kite for interoperability testing engine. And Google agreed to sponsor the project. And by 2 years later, we're testing 23 different browser configuration on different operating system, mobile, desktop, and so on, every day against each other to make sure that, oh, my call works in Chrome, but it doesn't work in Firefox, and why Safari on iOS is not working, and when is it going to work, and so on and so forth. So this is done on a daily basis. You can see the results on the webrtc.org official site, and that's half of this testing tool is actually open source, and people can just go and use it to test. Of course, interoperability is nice, but not everybody has 23 configuration to test. Most of the people are happy with only Chrome. What is more interesting? Okay, so Google uses it. They paid for it at the beginning. Microsoft uses it mainly for the UWP. So the Universal Window Platform is the build for HoloLens, Xbox, and so on and so forth. Apple uses it, so that's the last blog at the bottom where they give credit to this tool. Pretty everybody is using Kite today to test WebRTC because it's free and it makes it much easier. And there is not really anything else anyway. So interop is good. Load testing is better. The problem, there was always the same question coming back into the mailing list, which is, what is the best media server? With the definition of best that was varying so much that it was really, really, really difficult to answer. If you want a media server for streaming, it's not the same kind of scalability that if you want a web server for video conference, because the stream are only one way and they don't go everywhere. So the complexity in a video conference case is quadratic. So if you have n viewer, you have n square streams going around, while in the streaming one-to-many, it's linear. If you have n viewers, you have n streams. So we did the first study using Kite only for the video conferencing part. So it doesn't scale the same as the media streaming, so that's why we separate the use case. And we took the usual suspect, Janus, Midus, Jitsi, OpenVideo is Currento under another name, and MediaSoup, to show that by using a single tool, we can actually put all the media server in the same condition and have comparable results against each other. That was the first time that such a study was possible. So there's a lot of people, even in the media industry, that took one of those open source and started with it just to learn about WebRTC before they start removing the lines and doing their own. So it's a good thing. This is load testing, which is the bandwidth usage depending on the number of user participants on the media server on the bottom. again, to compare things, when you see 300 on the bottom, that means you have 300 times 300 streams going around, right? So if you were doing a streaming and you see 300 people, 300 streams on the result of some benchmark for streaming industry, this is not comparable to the 300 number here. Okay, Paul? Okay. This is the RTT. So Currento at that time was 1 year after the acquisition of the core team by Twilio. So of course they were in need of love and so on. That's why the results were not really good. They have fixed that since. Everybody else is pretty much the same. It's logarithmic. That means once you reach 300 people, you go from an RTT of 1 second to 10 seconds, right? So of course when you really get into the load, things start to slow down a little bit. But nobody had ever been able to see the comparison between those different guys and why they were like this. So Jitsi actually fell a little bit early. They fixed the bug since, but the idea was their scaling process was to have a lot of small machine instead of having a big machine. So they would actually not recommend to any of their clients to go all the way to sustaining 250 people in one conference. Because for video conference, when you have 20 people in the room, if you manage not to have them speaking over each other, you're already happy. So 250, forget about it, right? For the streaming, it will be quite different. Another problem with WebRTC testing tools is that you had a lot of tools to test the quality of the codecs. So Netflix come with WMAF that was extremely good, somewhere between subjective and objective, but you need to have the reference video. So when you're streaming something that is pre-recorded, there is no problem. You have the original video. But when you're streaming live content, you do not have that, right? And you still would like to be able to evaluate the quality of your stream, your live stream in real time to be able to act on it. So at CosMo, we did some research and we developed a new artificial intelligence based tool called Narval that gives you approximately the same behavior and the same score as SSIM and VMAF without requiring an original video. So you take the frame, you give it to Narval, and it gives you a score. It compensates the absence of original video by the training of the artificial intelligence, right? So that's all that done. So now you have a tool to actually use in real time to give you the same results than VMAF that could only be used with either stream that have a longer delay or a post-mortem or in a lab. WebRTC always-on encryption is heavy. We heard that from CenturyLink. Who thinks it right or wrong? Is the encryption really something that's taking CPU? Should we remove encryption inside the platform as a service? Who risk an answer? You on the front row? You ask for it. You don't know. Well, not anymore, right? So not since 2015. So the original WebRTC encryption was RSA, and we were still using SHA-1, for example, that has been completely deprecated across all the web browser because it was not resistant enough, and we went for the elliptic curve algorithm. So the advantage of the EC algorithm is that not only they're much stronger, so if you take a 124-bit key, is going to be as strong an encryption that a free 72-bit RSA key, right? But it's also much faster. So you had 1 second key generation and encryption before, and starting December 2015 with elliptic curve, it was just a few milliseconds. So not only the setup time, the encryption time was much faster, the encryption was faster, but also the complexity of the algorithm was lower. And that was really, really important for the mobile. Right? On mobile, you could spend as much as 10%, 12% of the CPU and battery, right, just for the encryption. And that was not acceptable. On the desktop, people didn't really care too much, 10%, okay, so what? On mobile, it was making a big difference on the battery life and everything. So since, I'm exaggerating, 47, was the first time. It was behind the flag. Starting Chrome 52 around 2017, it was mandatory. So nowadays, the encryption in WebRTC is negligible compared to the rest. So, okay, anyway, I have a platform as a service, right? So why I don't just remove the encryption when it's internal to my own network, because after all, I control it and I know what's happened. Well, you can do that. There is actually a lot of platform as a service that do that. So I took two examples, MediaSoup and Janus. That's two open source WebRTC servers that do only RTP forwarding. So since WebRTC is based on SRTP, the secure one, you just remove the encryption and you pass on RTP. So you don't need to transcode, you don't need to do anything. It's really natural to do like that. So the real WebRTC nodes are the first one and the last one for the viewer. So here you full WebRTC encrypted and so on and so forth. But internally to the platform, you only have a simple RTP stream. That works very well. It used to be interesting, it's not so interesting anymore. And then I saw some other people proposing RTSP or other things like that. RTSP is still very important in the security business because that's what most of the camera, the security camera will give you. The problem is that it's not encrypted. Anybody have seen those hacked American drone feeds? Non-encryption is not a good idea. And for people that don't remember that, Snowden showed us that it was really, really a bad idea. So this is the Snowden one of the Snowden documents from the NSA that explain how to hack into the Google Cloud, because the Google Cloud had a single front-end point of entry, and everything inside will be in clear text. Right? So nowadays, to give you an example of seriously people are taking that, I think this month or last month, Facebook announced that they're not forcing RTMP-S for people that wanted to actually stream to Facebook. And YouTube is following and so on and so forth. So you've seen all of the websites after the Snowden revelation say we only work over HTTPS. WebRTC, if you want to capture the camera, your site need to be served over HTTPS as well. And now we see people even at the streaming protocol also forcing that because, well, even your own government sometimes is not, taking care of you. Another solution, as we spoke again before, is to have double encryption. Right? If you have double encryption, if you're sending to your provider already encrypted data with your own key, even if they do the wrong thing or they get hacked or, the representative of the legal enforcement organization is forcing them to give them access to the server, they can only give access to something that is encrypted. Everybody followed the iPhone problem during the terrorist attack where the government were trying to force Apple to provide them the key. Well, even if they want, they can't. It's a dual key system, and there is a dual encryption, and the second key is not at the disposal of Apple. So again, Telegram, WhatsApp, it works. Safari does not support WebRTC. That's something I used to hear, and it used to be true until more or less this year or last year. There were some work from Ericsson, R&D, and some other people to provide it to them. It was only the technical part of the iceberg. We implemented WebRTC, we give it to them. So this is WebRTC in WebKit project that was started in 2015 with Ericsson R&D. That was not enough. And then they realized that there was money, and finally they flipped, I think 1.5 years ago. And nowadays they just make a blog post recognizing the state of the art and the contribution we had in bringing WebRTC to Apple as well. Edge was not supporting WebRTC, so it's funny, I saw today a presentation about from a WebRTC expert that was listing Edge. Edge never supported WebRTC. Internet Explorer never supported WebRTC. They had their own flavor of a non-compatible thing called ORTC. But that's okay now because they're using Chromium, so we're good. They broke WebEx and a few things last week again, but yeah, they're getting there. They're getting there. Encoder in WebRTC are slow. Who thinks encoder in WebRTC are slow? Okay, Paul, go for it. No, you think they're fast enough? They're actually pretty slow. Pretty slow, the software one. Oh, software. Yeah, so I'll give you half a point. Encoders in WebRTC are slow. And one reason for that is most of the people that in the streaming industry, like Netflix, that stream pre-recorded content will focus on the decoder speed. They have all the time in the world to encode. They have multi-pass algorithm. They're going to use machine learning, per title encoding, and so on and so forth. They're making the difference based on the fact that they have a lot of time to actually encode. But when you decode, that's the user experience. So it needs to be fast. The example is AV1, for example. You have David and a few projects related to AV1 codec that are decoder only. Because really, that's the only thing that they really care about. It's not the problem of any people. So Netflix and YouTube provide some self-encoded data set for people to try the decoder against. And Firefox announced, I think in October or November last year, support for AV1 in Firefox. But of course, by that they mean support of decoding and not in WebRTC, right? Well, you know, fair. Well, we'll go into other claims by other people somewhere. Let's go there, right? So what's the problem really? If you want to decide what is slow, you need to know what is fast, right? So what is the fastest you can go? So if you look at the different encoding speed on GPU on a single computer, shared memory, you know, life is good. The average is 11 milliseconds, right, per frame. That's for 720p. So you can take between 5 and 15, and that's as fast as you can expect to go. Now, what about AV1 and LibAOM and things like that? What is the speed we achieve today? So that's the latest. So every week for the AOMEDIA, of which we are a member, we do the benchmark for everybody. That's AOM 1080p 720 NVGA, and that's the Intel encoder, right? So those are only encoding speed. And you see that LibAOM is not progressing a lot in terms of speed, or in terms of FPS, right? But AV1 from Intel was actually under work a lot, and not so much recently again, right? And here is the announcement by Netflix and Intel about the real-time codec. So what's interesting is this. So this is a logarithmic scale. So this is 1 frame per second. This is 10 frames per second. And then you go 20, 30, 40, 50, 60. So VGA, nobody really cares for streaming, right? So let's be serious. 720p, you can achieve almost 30 FPS with 720p today. But that's on a Dell XPS, you know, normal stuff you can buy at Costco. Not a special hardware at all. You can already achieve 30 FPS. But the question, the 1 million question is 30 FPS real time or not? And unfortunately, this is really misleading, and the press release from Netflix and Intel are already misleading. 30 FPS is the throughput. It's not the latency. So you can do 40 plus FPS with the Intel encoder, but with 6-7 second latency. That's the problem today. This is not a real-time codec. How do they do that? Well, it's a little bit like bandwidth, right? You can have 1 gigabyte per second connection, but it goes over satellite, and so the round trip is 1 second. Here is the same. They encode a lot of frames in parallel, so they achieve a global throughput of 40 or 60 FPS. But if you compute the latency, which is the time between the output of the capturer when you get the raw frame and the output of the encoder where you had the encoded frame, then it's 7 seconds. And one of the reasons for that is they have a huge frame buffer of 72 frames. And so you need to fill that buffer before you can do anything, because that's not a real-time codec. Codec that go for the quality, they need to have inter-frame prediction. They have motion vector, they have things like that, which require to have several frames at hand to be able to do this computation, right? A real-time codec, well, if you need 10 frames in a buffer and the acquisition of a frame is 10 milliseconds, you already lost 100 milliseconds just to fill your buffer at the beginning. It's not acceptable. So most of the real-time codec will do 1 frame per second. They will do intra-frame prediction and encoding and so on, but they will remove everything that requires to have several frames in the buffer. So that's the notion of real-time codec. So actually, within AV1, within AOMEDIA, there is a real-time group within the codec group that nobody knows about almost. So the goal of AOMEDIA is to do AV1. Most of the people want to use it, most of the members of AOMEDIA want to use it as a normal codec, like Netflix and so on. But there is a group of resistance that try to use it also for real-time communication. So we are part of that group. The focus of the group is real-time encoding. So have something with a minimum latency, even though the compression ratio is not as good as what you would have otherwise, right? So the compromise is more on the latency and less on the quality. Optimization of the bit stream so that the bandwidth usage is good. Here again, Does it matter if my first packet takes a lot of bandwidth compared to my next packet? Well, if I'm Netflix and I'm writing on disk, the only thing that matters is the time it takes and the global size of the final file. It doesn't matter if each packet don't have the same size. But if I'm streaming in real time, fluctuation of bandwidth usage is going to impact it a lot, right? RTP payload specs, so how to use AV1 in the RTP media transport protocol, and RTP level optimization, so that if I use AV1 in real time with RTP, I actually get better latency than if I use AV1 otherwise, by dropping some of the packets that I know I don't need even before they reach the decoder. And so my decoder complexity reduced because it's getting fed less data, right? Google slide, internal AOMEDIA. We suppose this is what they did for Stadia. They don't say. But they are the only one that have data on existing implementation of SVC for AV1 and VP9. So what they show, and this is super interesting, is that for real time, if you take the normal AV1 and you do the packet, the first packet, because it's a full frame, is going to use a lot of bandwidth in blue, and then after, much less. So the problem is you need to have, if you want to do it real time, you need to have a bandwidth available that fit the worst case scenario. Otherwise, you're going to have a problem. And so they propose new modes of chunking the AV1 bit stream in such a way that that difference between the worst case scenario and the average is getting reduced, and so you can be a better bandwidth citizen for real-time codec, which is, again, not something most of the video on demand, I would say, or pre-recorded content streamer would care about, but important otherwise. So here are the K SVC mode, and it can look like that. And I will leave it at that. If there are some codec people that want to speak about it, we can speak later, but it's going to be interesting. The other thing is, you want to reduce the complexity of the decoder, right? Especially in the real-time case. So you're going to use this one is going to be in the codec itself, in the bit stream. So everybody is going to benefit from that. This is something that is going to be specific for AV1 in RTP. So if you use RTP, you're going to be able in advance to have in the RTP header an indication of which packets are important to you and which you can drop. And so now you can decide before you reach the encoder, just by looking at the packet on the wire, which packet you can directly drop and not even feed to the encoder, and life is going to be okay. So that's the first time that you actually have a decoder point of view into RTP. So before, everything was in the encoder, and you suppose the decoder was dumb, and even if the decoder complexity was going up, that's life. So now we do a different trade-off, where we're going to add a little bit of information in the RTP header in exchange for decreasing a lot the decoding time and complexity. So that was about AV1 and real-time codec. Let's speak about backend feature, right? So very, very often I hear, oh, WebRTC doesn't have this and doesn't have that. Very often it's in a WOSA blog. People do not remember that WebRTC is a media transport. You know, that includes the codec, but it's still a media transport. So if you want to do the analogy with Flash and RTMP, RTMP was not in charge of recording. The RTMP server was in charge of getting the media and recording it. That was a back-end feature, and WebRTC is exactly the same. So WebRTC is a standard on the client side, but not on the back-end side, and it also does not standardize the signaling. So if you say this, and this is missing from WebRTC, I say no, that's not the role of WebRTC to do that, but you're going to need more than WebRTC to have a full system, right? So if you want a full system, you're going to need a media server, you're going to need the login, you're going to need this, and that. You're going to need server-side ad insertion if you want to support some business. Is it the role of WebRTC? No, it's not, right? There is another protocol to support for that, and it's fine. It's totally normal, right? So it's going to get there. So WebRTC does not have ABR. That's why we did it server-side. Phoenix, RTS, or RAID 5. The jury is still out there. To be honest, it's a fair point. Okay? So let's be honest. At the time those two vendors made that decision, they were perfectly right. If you had to implement a fully working system with a correct quality of service, you needed to have ABR. And at the time they did it, ABR was not available on the client side. So of course, it was supposed to be in WebRTC at one point, but nobody knew at that time when it's going to get out and when it's going to be available and what it's going to be. So if you had to make that decision today, you should not do it on the server side, right? It's been available for previous generation codec. They did some work around called simulcast. And the spatial scalability was merged on May 2nd, right? So you could not expect people that has done in the past to wait for that. If you do it today, it's here. Okay, so don't worry about it. For the current generation codec, 265 or VP9, SVC, the full scalability is already in, so let the codec do the job. Don't worry about simulcast and all of that. It's going to be included for you. And for AV1, I showed you before that this is going to be a central piece of the improvement of AV1 and so on and so forth. Why should we care? Well, for two reasons. First, if it's done, no need to spend time doing it. Two, if it's done by the browser vendors in a standard body and you want to interoperate with the browser vendors, you better do the way they did it and not a different way, right? So there is always a fine line, which is to say, okay, if I know when it's going to arrive and it's far in the future and my client cannot wait, I'm going to do it my way, knowing that I might need to redo it later. And I think that's the case of the two vendors that I mentioned before. Otherwise, if it's not too far away in the future and so on, it's better to leverage the 1,500 engineers in Chrome that are going to do it and test it beyond what I'm going to be able to do. So WebRTC doesn't have surround sound, so it's never going to be good for gaming and so on and so forth. That's something we hear a lot from Microsoft when they try to push the Xbox or Mixer and so on and so forth. For those who don't know, the original Mixer was based on the Janus open source server, and they just made a mix between RTMP and WebRTC. And one of the mix they did was to add support for the AAC audio codec within the WebRTC stack, right, to be able to support 5.1 and things like that. Well, that also changed. Opus, which is the high-quality codec mandatory to implement in WebRTC, now support 6.1 channel. I think they did it in purpose, not to do 5.1, but 6.1, since 29th of April to 2019. So now you can go in Chrome with the latest version and start playing with a surround sound with Opus. It's pretty nice. So you have the link and so on. So let's resume what we learned in the past 2 years while we were trying to set up a WebRTC platform as a service and helping other people get there as well. We think, it's an opinion, that the first maturity phase is solved. So the scalability problem is pretty much done. There is enough vendor out there that can scale to high enough number that WebRTC can be used for streaming. And I don't think anybody today can really come and say it doesn't scale anymore. It used to be something that you hear very, very often 1 or 2 years ago. The protocols are final and stable, and almost all the browser vendors have them. So that was one of the biggest problems in terms of reach. Safari was late to the game, and God, people love the iPhone and the iPad, right? So if you could not support those devices, you had a problem. So an example to show you how commonplace WebRTC implementation of quality are today is that you do not only have the usual academic spin-off with the WebRTC server in open source and so on. 1 month ago, Intel actually open sourced the entire Intel Communication Suite was the name. So they call it Open WebRTC now. Open WebRTC Toolkit, sorry. It's all on GitHub, so you have Intel level quality of media server, all the mobile SDK, all the desktop SDK. They add support of 265 in WebRTC, which is not by default, and so on and so forth. So people that would like to start today with a code that is well written, and they have very, very good base to start, which was not the case 2 years ago. And so on and so forth. So I wanted to give you another example. So bloggit.me is maybe the most active blogger in the WebRTC space, maybe a little bit less known in the streaming space, and it's keeping list of WebRTC developer tool, landscape, and so on and so forth. I saw today someone presenting on WebRTC and say TalkBox, for example. You have actually a lot of services. TalkBox is part of Nexmo now. They both have been bought by Vonage, and they've been integrated together. But if you take Nexmo or TalkBox into account, well, they have other people, right? So you have WebRTC service. Most of them, with the exception of Phoenix here, are more video conferencing oriented, so the pricing and so on will not be adapted to streaming, right? But if you want to give it a try to WebRTC and see how developed the ecosystem and mature is, you have a lot of examples here. Testing and monitoring, I spoke to you about Kite. There is a hosted called TestRTC, and Colstat.io is the de facto standard for monitoring and testing. Amazon Alexa, for example, is using Colstat.io, right, to give you an idea. Here you have all the media server you could start from, right, the usual suspects, and then actually quite a few others, right? So I'm not going to tell you which one I love more. You know, that's your choice. Each of those are different enough that they will not fit all the use case. So you need to define your own use case and your own need, and then you go there. There's quite a few, which is interesting, but not too many, so that you can still go and test and decide which one is good for you. We're still working on cleaning all of that. Thank you, Edge is gone. Opera, not really. And then you have other stuff. So I don't think you're going to be interested in voice over IP and the rest, but everything else is pretty much interesting for people that, you know, want to get an idea of what's out there, or maybe start something and get a prototype. So what is interesting is also to learn from the people that have done it, what not to do, and to save your time. So we try to give you a few indicators of what you should not do. And if you're doing it, you should stop right now, right? So you're likely doing it wrong if you had a WebRTC implementation for many years, right? I explained to you there were some choices that made sense when it was done 2 years ago, but given how fast the technology has matured recently, you have to revisit it. And I will give you the most famous example that nobody can really say out loud at the working group is Facebook. Facebook has a WebRTC fork for Facebook Messenger that dates back from 2012. And it's not working with any browser anymore, and they keep putting tickets against all the browsers to tell them, you need to change. Okay, Facebook Messenger is the #1 app. It's the biggest traffic. They did 16 billion calls in 2017 over WebRTC and so on. So they have a certain weight. But to go there and, you know, ask Mozilla, which is a non-profit organization, to fix a bug so that they fit DTLS security hole. So please keep the DTLS security hole open. Do not move to 1.3 because otherwise, you know, our stuff doesn't work anymore. No, I'm going to keep the web safe. If you don't have an end-to-end layer, some people call it a director API, some people call it media stream management and so on. It's likely that you're doing something wrong or the thing is going to explode in your face. If you mix with other protocols in a way that requires transcoding always, and the always is important, right? You're likely doing it wrong, right? You need to have a way to have WebRTC end-to-end when it's possible, when people go from one browser to another, or when something that can stream WebRTC in all the way. That's when you can achieve the best latency. If you don't have that, if you transcode all of the time, even if only flash ingest, you already have a twice worse latency that you could have with WebRTC. Well, you could be well under a second, that doesn't matter, right? But you're not getting the best you could get out of your platform. There's a little asterisk there. It's not always possible. Some people have hardware that cannot, you know, output WebRTC. You don't. We have modified OBS, for example, to add WebRTC support in OBS, but that's because OBS is open source. If you take XSplit or other stuff that are used in streaming, there's nothing we can do if they don't want to do it, right? Finally, if you do not have support for all major browsers, desktop, mobile, and native SDK for mobile, you're missing something. There is enough open source SDK out there nowadays, especially with the Intel one, that you can just take the code and make your own SDK and support all those platforms. So there is a lot of people that think WebRTC is a server game. Actually, the client side is a little bit difficult. But now people have done that for you, so you should be able to integrate that from the get-go by, you know, doing your homework and going after those guys. If you go back to here, you will see that you have some SDK and plugin for Internet Explorer provider here. It's a small list, but those guys can help you with commercial package if you don't want to take an open source one. So, what's next? You know, what's coming in the next 6 months, and then what's coming next year? So here it's more prediction. What we think is, since we finished the base, which is to address the need of people that are only interested in latency at a certain scale and quality, now what is going to be difficult is to have feature parity with HLS and normal CDN and things like that. So you need to increase the value for existing customer, recording, monitoring, end-to-end encryption. Those things, as far as I know, do not exist or are not provided by any of the WebRTC CDN vendors today. Enable additional revenue model, so find a way to understand how to do ad insertion live in a WebRTC stream in a way that is compatible with the ad brokers today. So that means, what's the pronunciation of that word, Richard? Correct me again. SKITE 35 marking in the media. The capacity to handle vast requests to the ad broker, and so on and so forth. And finally, so that allows YouTube-like advertised-based revenue model that are not supported today with WebRTC. Finally, another revenue model protecting high value content requires watermarking and DRM, which, as far as I know today, doesn't exist in conjunction with WebRTC. And to prove that it doesn't exist, that's actually where the usual vendors, so that's Verizon Digital Media, their newsletter from this week, and that's Limelight Network. When they want to make the difference for live streaming now, they don't try to make the difference on latency. They know they lost this war to WebRTC a long time ago. So now they try to couple it with a feature that they think WebRTC doesn't have, right? So watermarking, server-side ad insertion, ad-supported live event, right? So that's how this week the traditional video CDN vendors are positioning their live offer with respect to WebRTC, right? That's basically what they say between the lines is you cannot do that with WebRTC. So if you want live event and ad supported, take my traditional technology. What about next year? Well, it depends who you ask to. If you ask Google, they made it very, very clear, AV1, Quick, and WebAssembly, right? So the low-level API in the new WebRTC will allow people to bring their own codec in JavaScript, right, or in whatever language. Unfortunately, JavaScript is not fast enough, and that's where WASM is coming in to actually have some pure web-based encryption and encoding. And so then you do not depend on the browser implementation. You're not constrained by which codec they support there. You only constrained by the CPU and the capacity of WASM. Quick is super, super hot. I'm not even going to go there. And AV1 is a new codec. We spoke a little bit about that. Obviously, for them, you can read the subtitle here, Stadia, right? I want a better compression with a better resilience to network bad quality on a transport that is faster to make an establishment and that can multiplex a lot of things, data and so on. One fantastic use case for Quick is that you can have perfect synchronization between the data and the video frame, which you cannot do today with the data channel in WebRTC. That means AR, right? For AR, you need to have the data that is exactly synchronized with the frame. And today is not exactly that. So even if you look at all the Facebook and all the other AI or VR stuff, you see it's lagging a little bit when you move. And that's because the data channel and the media is not synchronized. With Quick, you're going to be able to have both on the same transport with the same timestamp, so it's going to be synchronized by design. According to Facebook, it's quick. Quick and quick only. And actually, I could put Akamai here. Akamai is like, I don't want WebRTC, I'm going to jump directly on Quick, and I'm going to do media over Quick, and it's going to be awesome. I don't know how it's going to work, but it's going to be awesome. So Facebook open sourced their stack last week. Fantastic implementation, very high level. They're using in production. The code is clean. So far, there were 13 implementation of Quick. They were more or less academic or for people working on the standard itself. They have been using that in production for a year. So they actually not only provide a Quick stack, they also provide the server for load balancing and so on and so forth. The entire thing, it's beautiful. So if you want to learn about Quick, don't read the spec. Go directly on the GitHub. it's really good. According to AOMEDIA, Intel, and Netflix, it's AV1, right? So there is a little bit of strategy there. The reason why Netflix and Intel have made their announcement about real-time implementation of an AV1 encoder is also because they're trying to position themselves for AV2, right? So they want to replace the libAOM, which is the official implementation that the AOMEDIA members use, by the SVT AV1 implementation by Intel and Netflix. And that would provide them a little bit more leverage in the discussion and a political thing going inside AOMEDIA. But it's a good codec if you're not looking for real time. If you're looking for video on demand streaming, it's really good and it works super fast, even on a normal Dell, off-the-shelf hardware. So, how to keep in touch with all those rapid innovating fields? There were at least half of the slides about things that happened in the past 2 months, right? That's completely crazy. You can join the standard committee, W3C, IETF, AOMEDIA, ITU, MPEG. I'm missing a few. You will travel a lot, different time zone. I always enjoy the call at midnight from Singapore, so that it's 9 a.m. in California. But if you live in California already, it's going to be okay. Or you can read my tweets. It's going to be tech only. There will be no marketing, no bullshit. And it's going to be tainted with my French accent and arrogance. But apart from that, it's going to be a way to digest all of this stuff and go there. Right. So thank you again for joining us on that session. And if you have any question, floor is yours. Yes.
In terms of what kind of client support does WebRTC have, say Roku, Smart TV?
It's up to you to do it. You need to find someone that either provide an SDK for you, or you need to take the WebRTC.org source code and try to compile it over. We had some people coming to us to do that. We do that a lot for Samsung TV, for Tizen OS. Tizen OS 2019 will have a version of Chrome that supports WebRTC, but before that, you needed to compile it yourself. So most of those TV have SDK and so on. It's not very difficult to do, with the exception of Roku, right? So Roku doesn't really open their SDK. They're a little bit difficult to speak with, but for the rest, there is enough code available that you can compile it yourself.
And is there any CDNs which by design handles WebRTC well?
By design, no, because WebRTC is a live streaming, and most of the CDN today, they're HTTP transport-based and file-based for the format. But you have example of Limelight Network and other people that are really trying to see how they can integrate it on the side, meaning on the same node first, and eventually with a single platform. The problem with having it on the side is that the CDN is highly optimized in terms of network. And if you have two protocols that live next to each other, they're going to compete to get access to the bandwidth, and it's going to screw all the algorithm and their routing and so on. So as far as I know, Limelight is using RAID 5 technology for a year now, and it seems to be okay. I'm sure there are other people that are using different options. They're just not speaking too much about it. Any other question? Yes?
So WebRTC was based off UDP to start. Does
Yes.
it also support TCP now?
So it was based on RTP. And RTP works better on top of UDP because RTP is only partially reliable. They know they're transporting media, so they know what to do if they lose a packet, right? While TCP and UDP are network protocols, so they're not supposed to do anything special with respect to what happened on the other stuff. So RTP could use TCP from the beginning and so on and so forth. They just didn't. Today, you can use WebRTC on top of UDP, TCP, DTLS, and TLS, so the secure version of them, either directly or through a turn server. All right, thank you everyone, and good keynote.